let's start this. 4, 5, 6, 7. You're doing number 4 and 5 from each section. So let's find the first difference. So 1, 1, 1. On the side, I'm going to write this as a table. So the first term of my sequence, the first number of my sequence is a 4. The second number is a 2. Is a 5. The third number is a 6. The fourth number is 7, and so forth and so forth. So you can write it this way. I'm not, it's okay. It's an n sequence. It's a linear. All the numbers are the same here, right? So we can stop. It's an n sequence, all right? So this number over here, that 1 would go here. It's a 1n sequence. So an n 1n sequence, if you substitute this n for 1, 1 times 1 would be 1. The second number would be 2, and 2 times 1 would be 2. So, and therefore 3, 4, 5, 6, 7, etc. And just to tell you that that 1, it's not necessary because it's implied. So basically, we're telling you it's a times 1, right? Times 1, times 1, times 1, times 1. But you need to make a little adjustments, right? So it's an and sequence for sure, but it's not enough to get to what we want, which is a 4, 5, 6, 7. So what adjustments do we have to make to the and sequence? So how does that 1 get to be a 4? How did the 2 get to be a 5? And 3 becomes a 6? And how did the 4 becomes a 7? So if you look at it, it's an and sequence, but plus 3. If you check, let's check for n equals 3. When n equals 3, or the third term, which should be the first, second, and third term, you should get a 6. So let's make sure we get a 6. So when you substitute and n equals 3, you get 3 plus 3. And indeed, you get a 6. Check one more time. Here's my n plus 3. So let's take it the fourth term. The fourth term is a 7. So let's see if I get a 7. So when n is 4, I get 4 plus 3. And I indeed get a 7. Okay, so that seemed to work. So these are the easier ones, the linear sequences. Okay. 5, it's 2, 9, 16, and 23. It looks like it's plus 7, right? 7 plus 7 plus 7. So there's my sequence is going up by 7. So it's a sequence that's always going to go by 7s. Therefore, well, I know it's a n sequence, but what kind of n sequence? It's a times 7, a 7n sequence. So in a 7n sequence, my first term would be 7. 2 would be 14, my second term. My third term, if n equals 3, I could get 3 times 7 is 21, and 28, and so forth. So you notice that it's a also plus 7, plus 7, plus 7. But you notice that I don't really get the 2 or the 9 or 16 or 23. So I have to make an adjustment to this n sequence, the 7n sequence. So I get the 2. So this would be a 7n sequence. But how did the 7 become a 2? You'd have to subtract 5. And it does work for each of them. 14 minus 5 equals 9. 29 minus 5, 16. 28 minus 5 equals 23. Again, if you want to check, please do so. So let's take the second term here. The second term. The second term should result in a 9, right? So if I check, I get 7n minus 5, and if I substitute 7 times 2 minus 5, I get 14 minus 5, and I get a 9. Good. So what about when n equals 3? I should get 16. So 7 times 3 minus 5, 21 minus 5, and I do get 16. My third term is 16. And so forth and so forth. So just make sure you check for a couple of numbers. So the sequence for this is 7n minus 5. So if I were to ask you, so well, we're going with numbers, right? And down the line, if I asked you, hey, what would be the 40th number in this sequence? Well, first, second, third, fourth, all the way down the 40th term of the sequence. Well, you can use now this thing over here. And you get 7 times 40 minus 5, 280 minus 5. And the 40th term of this sequence would be 275. And that's what we're trying to find out. Okay. Moving to the gold, silver, and 4 and 5 again. 7, 13, 23, 37, 55. So these will be in this format. Okay. 6, 10, no idea. No idea. So they're not the same, right? So that tells me I need to take a second difference. Second difference. Now it's all 4s, right? So I know this is a n square sequence, but I need to figure out if there's a number that comes in front here. What you have to do is take this 4, have it, right? And half of 4 is 2, and that's the number that's going to be put in there. So now we work on what a 2n sequence, 2n squared sequence is, right? So it's 1 times 2, which is 2. 2 squared would be 4 times 2, which is 8. 3 squared would be 9 times 2, which is 9 times 2 is 18. N squared would be 4 to the second power is 16. 16 times 2 is 32, and we need to do one more. 5 to the second power is 25, times 2 is 50. So we have our numbers. Subtract. We're going to be subtracting our first sequence here. This sequence. 7 minus 2 is 5. So you notice that everything is 5. Right? 5, 5, 5. So no adjustments here necessary. Let me go back. So my sequence is a 2n sequence. We have to make a little adjustment. So, because if I do a 2n sequence, 2n squared sequence, I get 2, 8, 18, 32, 50, etc., etc. But what I really want is this: 7, 13, 23, 37, 65. So how do I adjust that so that I get the 7 to 13? Well, it's 2 to 7 is plus 5, 8 to 13 is plus 5, 18 plus 5. So it's a 2n squared plus 5. Double check. Let's pick this one. This is the third number in our sequence, so let's substitute with n being 3. So I get 2 times 3 squared plus 5. 3 squared is 9, times 2 is 18, and then plus 5 is 23. Is that what I have? Yeah, 23. Let's check the fifth term. The fifth term is 2 times 5 squared plus 5. 5 squared is 25, times 2 is 50, plus 5 is 55. Okay, that worked. So again, always double check at least a couple of times. Okay, so my final answer, the answer term is this. I can use this to find any term in this sequence. Okay. 5, I believe. 1, 3, 33, and I don't know why I'm putting the comments. So then again, 1, 13, 33, 61, 97. This is a 12, this is a 20, this is a 28, this is a 30-something, 36. They're not the same, so that tells me that this is a quadratic sequence, so it's an n square sequence. I got to figure out if there's a number in here. Take the second, which is 8, 8, 8. Okay, I stop. So half of 8 is 4, and that's the number that comes here. So this is a part of this is made up of a 4n sequence. So when n equals 1 is 1 squared times 4, which is 4. N equals 2 is 2 times 2, which is 4. 4 times 4 is 16. 3 squared is 9. 9 times 4 is 36. 4 squared is 16. 16 is 64. 5 squared is 25, and 25 times 5 is 100. So let's subtract these two. 1 minus 4 is negative 3, negative 3, negative 3, negative 3, negative 3, right? If you subtract that line minus this, you get that. So they're all the same, you can stop. So it's a 4n sequence, right? But I need to get there, so I minus 3 to make that a little adjustment, right? So it's a 4n sequence, minus 3 I get to the 1, so forth and so forth. So let's just try, let's pick the second one. So when n equals 2, I should get 13. Well, 4 times 2 squared minus 3. 2 squared is 4. 4 times 4 is 16. Minus 3, I get 13. Check. Let's try 97. My fifth term should be 97. So 4 times 5 squared minus 3. 5 squared is 25. 25 times 4 is 100. And I do get 97. Okay. And we got to do the next page. 4 and 5, I think I said. So again, 3, 17, 39, 69, 107. 14, 21, 28, and 30. Uh-oh. 14, that's not right, because I hurried. 14, that's right. 39 to 2, I need 2, sorry. And this is 30, and this should be 38. Better. So it's obviously they're not the same. You're going to find the second difference. So I'm already going ahead of myself here. And so I know it's an n square sequence, right? So it's not a linear sequence, not an n sequence, it's an n square sequence. Now I got to figure out if there's a number that goes in here. So let's do, it's 8. Is it 8? Yeah, no, yes, yeah, 8, 8. Take half of 8, and it's 4, so it's a 4n sequence. Okay, so a 4n sequence, let's see how it runs. When n equals 1, it's 1 squared times 4, which is 4. N equals 2 is 2, 4, 16. 3 is 9. 9, 3 squared is 9. 9 times 4 is 36. 4 squared is 16, and that's going to give me 64. 5 squared is 25 times 4, that's going to give me 100. So let's subtract. Negative 1, 1, 3, 5, 7. Okay, so they're not all the same. So I know so far I have this sequence. It's a 4n squared sequence. I need to find the second difference, the other difference now. This is plus 2, 2, 2, and 2. So definitely this is a, what do you call, a linear sequence because it's going by the same numbers. 2, 2, 2. The first difference here is, so it's a 2n. Okay, so it's a linear sequence, an n sequence, but this 2 comes right here. You don't have to half that one because it's linear. So a 2n sequence is 2 times 1 is 2. 2 times 2 is 4. Nope, it's going to be a 6. 2 times 3 is 6. 2 times 4 is 8. And 10. So I know that it's a 4n squared plus 2n. And how did the 2 become a negative 1? How did the 4 goes to 3? How did the 6 go to 3? How did the 8 go to 5? So you got to make a little adjustment, and that adjustment is going to be minus 3. Right? Check. So let's check our second one this time. Our second term in the sequence 17. So if I replace the n with 2, I get 2 squared. That's 2 times 2 minus 3. 16 plus 4 minus 3. 16 plus 4 is 20 minus 3, and I get 17. Yes, it works. Let's check first term, 3. 4n squared plus 2n minus 3. So this is my first term, so I'm going to substitute the n was 1. So I get 4 times 1 squared plus 2 times 1 minus 3. This is simply 4 plus 2 minus 3, and 6 minus 3 equals 3. Look at that, it worked. But 2 numbers should be plenty. Definitely more than 1. Okay, so my sequence here is this, and I can use this to find any number in my sequence, whether it's the first term, the second, the third, the fourth, the 100th term, the 1,000th terms. I will use this. That it? Oh, I got one more. 5, 18, 37, 62, 93. So find the first difference is 13. This is 19. 19. This is 25. And this is 31. Yep. They're all the same, so it's not linear. It's a quadratic, so it's not n, but it's going to be an n squared. We need to figure out what that number is. Well, let's take the second difference. 6, 6, 6. So we're going to have 6, and we get 3 here. So this is a part of it. It's going to be a 3n squared sequence. So when n equals 1 is 3, 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, times 3 is 48. And what is this? 4 squared is 16. 5 squared is 25, times 3 is 75. Let's subtract. We get 2, 6, 10, 14, and this should give me 18. So part of my sequence already is a 3n squared sequence. And then let's take the first difference here. If you take the first difference, you get 4, 4, 4, because that's my first vertical difference. It's a linear, but it's a 4n sequence, right? It's going up by 4, so if you're going up by 4, it means it's 4, 8, 16, nope, right, 12, 16, 20, right? When n equals 1, first term is 4, when n equals 2, second one is 8, when n equals 3, it's 12, and so forth and so forth. So 3n squared plus 4n, do we have to make any adjustments? Yes, we do. Well, because we really want a 2, so 4 to 2, it's minus 2, 8 to 6, so you can tell it's minus 2, minus 2, minus 2, right? If you take, how did the 4 become a 2? Subtract 2. How did the 8 become a 6? Subtract 2. So it's all that. Make a little adjustment. Minus 2. Double check. Let's pick the fourth number. It should give us 62. So when n equals 4, 3 times 4 squared plus 4 times 4 minus n. Sorry, minus 2. 16 is 48. Plus 16 minus 2. 48 plus 16 is some weird number, 64. Minus 2, and I get 62. So you see, it does work. So let's try the first term. When n equals 1, I should get 5. So I get 3 times 1 squared plus 4 times 1 minus 2. 3 plus 4 minus 2. 3 plus 4 is 7, and minus 2 is 5. And guess what? That's exactly what I have as my first term. Oh, here it is. So you have a few other things. So we're going to do. So we have a few to do. So first one. So the equational line is this, right? Where y and x represents the coordinate of a point that you can substitute in here with the slope and with the y-intercept. So in this case, I know that the slope is 4 and the y-intercept is 3, so this is just y equals 4x plus 3. Second one, this one, a little tricky. Right, slope, so again, y equals mx plus b. Notice that we do have the slope, and the slope is negative 2/5. Okay, the negatives doesn't matter where you put the negatives. With a 2, with a 5, if you want to write it like this, or like that, or if you want to actually write it like this, it don't matter. These are all represents the same number. Okay, so now if I, I substitute that, I'm going to get this. Y equals negative 2/5x plus b. Who are we missing? We're missing the b. Now, do I have a point? I do. Not in that term, but a point I do. So I can use this point to put it over here and here, and to find the value of b. Right? So remember, this is your x and this is your y. Well, let's use that. Y is 1, negative 2/5 times x, which is 5, plus b. That's now becomes a very simple equation. Let me just cross this out because 5 and 5 multiplying, right? Becomes just 1. So I have 1 minus 2 plus b. Add negative 2 to both sides. Add 2 to both sides, my apologies. That crosses out and b equals 3. So now I know my intercept is going to be 3. So I have all the information I need. I can rewrite this again. Y equals mx. M, the slope is negative 2 over 5x. And my y-intercept we just found is 3. Okay, so moving on. So now this 5 and 7 is where you pretty much have nothing and you have to work to get to the equation. So again, we want y equals mx plus b. We need to find b and we need to find the slope. So there are 2 points here. So again, let me draw this. 2, 0 will be 2. So here's a point 2, 0. 4 and 4 would be 4 going that way, 4 going up. If I were to connect those points, that would be my line. I can tell that this is my y-intercept where it crosses the y-axis, and I can tell you that this is going to be a positive slope because it's going up. So all that just from the little diagram, which you don't need to do, but it just gives me an idea of what to expect. So let's call this x1, y1. Let's call this x2, y2. Doesn't matter who. So the slope is, yeah, right? Y's always have to be on top. Okay, so change in x and change in y. I'm finding the difference between the x coordinates and the y coordinates backwards. The y coordinates and the x coordinates. That's what I'm doing here. Right, so imagine you were here and I was here, right? So as far as height goes, this height, what's the difference between where you are and I am? How many floors apart are we? And likewise, on the x, when you're doing x2 minus x1, you're finding this, right, are the distance between us on the x-axis. So that's pretty much what we're doing. So y2 is 4, y1 is 0, it's 4 minus 0. x2 is 4 again, and x1 is 2. All right, so these 2 points are your x2, y2, and these 2 points are your x1, y1. If you subtract, you get 4 over 2, and 4 over 2 is just 2. All right, so now we have our slope, which, if you go to your equation, you're going to get y equals mx plus b, right? So I mean, you can leave 2 as it is, or 2 over 1, however it is. So my slope is a 2 right now. I need to find b. Pick either this point or this point, not one coordinate from each. You gotta pick a point, either this guy, 2 and 0, or this guy, 4 and 4. I would pick the one that has a 0. So if I use that 2 and 0 and plug it in, y is 0. A lot of you just wrote 2. It didn't matter to you that which one you put over here. Y is the second coordinate, this guy right here. Okay, it's the second number. The first one is the x. So substitute and get, so again, let me write this over here. So let me use 0.20. 2.20, y equals 0. 2 times, and the x value is 2, plus b. 0 equals 4 plus b. I'm going to subtract minus 4 on both sides, and I'm going to get that b equals negative 4. So that's my y-intercept. And sort of by the graph, look, you can sort of see that I was kind of right. Right? It's a line that crosses the y-axis in the negative area here, right? So the equation of my line is y equals m, which is 2, x minus 4. That's the equation of this line. Same thing here. So let's make that x1, y1, x2, y2. Let's subtract. y2 minus y1, x2 minus x1. So y2 is negative 4 minus y1, which is 3, x2, which is 0, minus x1, which is minus 1. So if I subtract, I get negative 7 on top, negative 1 at the bottom. That's just going to give me positive 7. 7 over 1, or just 7. That's fine. My equation, my line so far, I found my slope, right, m. So I can write 7x plus b, right? So I'm going from this. I just found this. Now I have to work on b. So pick one of the values over here. 1 and 3 or 0, negative 4, whichever one you use. I liked when I pick something that has a 0 because I don't have, it means less work. So let's pick 0, negative 4. So 0, negative 4. Substitute. So y is negative 4. And then I get 7 times 0 plus b. 7 times 0 is just 0. And I just get b. And my y-intercept is negative 4. How easy was that? So put everything together. Y equals, my slope is 7x. And my y-intercept is minus 4. So this is my final answer. Okay. And I believe there was something else. Yeah, yes. The absolute value. Your favorite. Okay, so absolute value, and you had questions 1 and 2. First one, negative 8a minus 3 is greater than 11. So this is an and, it's an or. Okay. For those of you who care about this, I'll do this step here. So when is this? When is the absolute value of something greater than 11? Well, to be greater than 11, I have to take the absolute value of 11.1, right? If I took the absolute value of 11.1, would that be greater than 11? Yes, because the absolute value of 11.1 is 11.1. Is that greater than 11? Yes. So that works. The absolute value of 1,000 is greater than 11, because the absolute value of 1,000 is 1,000. And that's greater than 11. So numbers that are on, that works. Absolute value of 10 is not greater than 11. So 10 doesn't work. 10, 9, 8, 7, 6, 5, 4, 3, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, negative 8, negative 9, negative 10 doesn't work. Negative 11 also doesn't work because it has to be greater, not equal. So negative 11 doesn't work. But if I take the absolute value of negative 12, will that be greater than 11? Yes, it will. Because the absolute value of negative 12 is 12, and that's greater than 11. So it has to be that way or this way. Okay, so all that just to tell me how to set up the problem. So now I'm going to set up. So this thing, the absolute value of this has two things. It can be greater than 11 or greater than negative 11. And that's, or less than negative 11, sorry. How are we going to set up? So here's my or. So the first one is take the absolute value out. Negative 8 minus 3 is going to be greater than 11. Or negative 8 minus 3 is going to be less than what? And here's that negative 11. Solve. The answers are there. I'll solve anyway. Plus 4, negative 8, plus 1 is greater than 15. Why am I doing plus 4? Okay, sorry. Plus 3. Let me get the 4. Plus 3, negative 8, less, greater than 14, right? Now I divide by negative 8, and then a is going to be less than negative 1 and 6/8, or 3/4. Okay, so let's just leave it like that for now. Now, this side, you're going to get negative 8 plus 3, and get negative 8 less than negative 8. Divide by negative 8, divided by negative 8, and a is going to be greater switch than 1. So let's graph this. When you graph this, things are going to be a little bit different, right? So a, there's a 1 here, has to be greater than 1. Or on this side, it has to be negative 1 and 6/8. Okay, so any number that is less than 1 and 6/8 will work, and any number that's greater than 1 will work. Okay, so what does that mean? That means that if I pick, let's say, well, let's pick a number greater than 1. Let's pick 10. But we'll substitute here. So here's my original. Let's pick a number greater than 1, 10. So I get negative 1, sorry, absolute value, negative 8 times 10 minus 3, greater than 11. Negative 8 times 10 is negative 80. Negative 80 minus 3 is negative 83. And if you take the absolute value of negative 83, it's 83. And is that greater than 11? It is. Okay, so it has to be. So pick another number. Pick 2, pick 3. So pick numbers on both sides for you to check. Okay, so the answer to this is x has to be greater than 1, or, sorry, not x, a has to be greater than 1, or a has to be less than negative 1 and 6/8. That's my answer. Okay. Now, I'm going to write this again. Negative 8 minus 3. So for those of you who are really not interested in me graphing, seeing what, if it was an and or or, know that if it's a greater sign, it's or. I know right away it's going to be an or problem, right? So you can right away set it. So this has to be greater than 11, or this whole thing has to be less than negative 11. That's your setup for or problems. Okay. 2 is that a v? V plus 5 minus 6 less than 5, negative 5. So the first thing we're going to do is add 6 here. We're gonna, all I want is my absolute value. So add 6 to that side, plus 6 to this side, and I'm going to get that v plus 5, absolute value of v plus 5 has to be less than 1. Okay. So this is an and problem. Okay. When is the absolute value of something, and again, I'm going to do, when is the absolute value of something less than 1? When it's, well, 0.9, is the absolute value of 0.9 less than 1? Yes. Is the absolute value of 3 less than 1? No. So you notice that numbers on this side not going to work. Numbers here, absolute value of, let me put a 0 here, 0.5 is less than 1. The absolute value of negative 0.5 is less than 1. So all these numbers do work up to negative 1. If I took the absolute value of any number between negative 1 and 1, not inclusive, it will be less than 1. Okay, so because it's an and, look at your setup. Now, if you want to ignore everything I just said and just go straight to your work, so you're going to take this guy over here, right? You're going to set it up like this. So it's going to be a 1. Negative 1 is on the other side, and v plus 5 goes in the middle, right? Now, to solve this, we're going to do minus 5 here, minus 5 here, minus 5 here. It's going to be minus 6, less than v, less than negative 4. So, if you graph that, here's negative 4, here's negative 5, here's negative 6. V can be any number in between this. So when I go back to substitute, so if you take this guy over here, absolute value of v plus 5 less than 1, and I say, hey, let's pick a value for v to substitute here. As long as it's between negative 4 and negative 6, not inclusive, you're good. Pick any number outside to the right of -4 or to the left of -4, it's just not going to work. So let's pick -5. So if I pick -5, I get -5 plus 5, which is 0. And the absolute value of 0 is 0. And is that less than 1? It is less than 1. Let's pick another number. Well, let's pick a, I'm going to pick a decimal. Let's pick this number right here, -4.5. So -4.5 plus 5, absolute value, less than 1. -4.5 plus 5 is negative, no, it's positive 0.5. And if we take the absolute value 0.5, 0.5, is that less than 1? It is less than 1. So the only values that will make this inequality true are values that are between -4 and -6. Okay? And we're done.